explain a motion in percent of resistive force. Okay, at first, what's meant by resistive force? Resistive force is one that inhibits or resists the motion of an object, and it acts in a direction opposite to the motion of the object. As an example, if the body moves to the right and there is resistive force act on it, it will act in direction of the left and try to stop this object or even um, move in the opposite direction, which is the direction of resistive force. And the most common example on resistive force is friction force. And resistive force is directly proportional to velocity of object, as in its rule, which is F equal BV, and B is drag coefficient or resistive coefficient, which is equal to 3.3 by 10 to the power negative 2 kilogram per second. By showing this rule, we concluded or notes that F is directly proportional with V, as resistive force directly proportional with velocity of object. Okay, if we have a body with mass m moving with velocity horizontally to right, then the resistive force acting on it will be in the opposite direction, which is on the left side. Resistive force. By calculating the force acting on the x direction, which is the summation of force in the x direction, which is equal m times a in the axis direction. And by assuming that there is no gravity, then it will have resistive force in the opposite direction, as in the example 1. Then it will be negative v in the opposite direction, and the negative sign is showing the opposite direction of the force, as max acting in right direction and the resistive force acting in the left direction, so it will be negative bv. Okay, by applying differential equation, so we will using derivative in the first step, as negative bv will be equal dv over dt. Then we will separate variables in the second step, as we will trying to get v in one side and the t in the opposite side. Negative b over v and by trying to get v inside and t in the other side, we will have negative pm dt equal dv divided by v. Okay, in the first step, we will integrate the both sides, as negative b over m as negative b over m constant, it will be it will not integrate. And as negative b over m is constant, it will be the same, and the integration of dt, or the antiderivative of it, will be t, and we will add c as a constant. And in the opposite side, the integration of dv over v will be ln v, as v in the denominator and its derivative in the numerator. So we will put ln a variable, which is ln v. And to remove ln, we can raise e, which is Euler constant. Then it will be e to the power negative b over m t plus e to the power c, and in the opposite side it will be e to the power v, the power ln v. And as e remove ln, so it will be only v. We can write it after removing ln, e over negative b m t plus e to the power c equal v. And as e power c is constant, as e is Euler constant, which is 2.8, and c is constant, which we put it after integration, we can represent e to the power c. We can replace it with k. So it will be e to the power negative e over m t but we can replace e to the power c after the next step. From the properties of e, we can replace the addition property with multiplication. So it will be e to the power negative b over mt times e to the power c, which is equal v. And then we can replace this constant with k. It will be k e negative vm times t equal v. And to know the variable k, we can assume that v is v initial at t equals 0. Then it will be at t equal 0 and v equal v initial. So it will be k e to the power negative b over m times 0, and as t equals 0, it will be v initial instead of v, and negative b over m times 0, it will be 0, and k power times e to the power 0 equal v naught, and e to the power 0 equal 1. Therefore k equals v naught. Then finally we can rewrite the equation as it will be the same of this, but then the new step that we know the value of k, which is equal v naught. So we can replace k by v naught times 2e power negative p over m t equal v. There is a proof of this equation without gravity. And if there is a gravity, it will be g e to the power negative b over m